Hello, class. Today we're going to talk about chemical reactions. Chemical reactions are what we can think of as chemical sentences. They represent the sentences in the language of chemistry. So it's just a way for us to communicate any type of chemical change by using symbols and formulas to represent the elements and the compounds that are involved in any chemical reaction. So what is a chemical reaction? It's a process by which we have starting materials, which we call reactants, and they're converted into new substances that we call products. These products have completely new and different properties than the starting materials. Any type of chemical reaction involves chemical bonds being broken and chemical bonds being formed. So how do we measure and how do we do calculations with tiny atoms and molecules? Remember from, week 1 and 2, we learned that atoms are the smallest particles that you can have. They're subatomic particles that can only be seen with the microscope. We can't see them with our visual eyes. So what chemists use is a unit called the mole, and this is what we use to link the unseen to what we actually can see in the lab. The mole kind of acts like a bridge. It links the submicroscopic world of atoms, molecules, and ions, which we learned about during week 2, to the macroscopic world of grams. And we know that grams is a unit that we use to measure mass. So we can link moles to grams. This is 1 mole of CO2, carbon dioxide, 44 grams. This is also the formula mass of carbon dioxide, 44 grams. So do you see the link between 1 mole and the formula mass? 1 mole is simply equal to the formula mass of a compound or an element. Now, what is the formula mass, you may ask? This is simply what we call the formula weight of any substance. It's the sum of all the atomic weights in atomic mass units, which is AMU, of all the atoms in the compound's formula. So when we look on the periodic table, what we see is a number. We see our atomic mass at the top. We see the atomic number. But we also at the bottom see the mass. This is what we call the formula mass of the element. So if we have 5 elements in a compound and we want to know the formula mass for the compound, we simply add up the individual masses of each element, sum them together, and that's the formula mass of the compound. We're going to go through a few examples in a minute. So molecular weight is only correct when used for covalent compounds, and we know covalent compounds are simply bonds between nonmetals. And it's calculated the same as the formula weight, but it's just a different term. The term would only be used for covalent compounds. This is just some extra information you really don't need to know. So of course we know what this is, right? This is the periodic table. This is where we're going to find the formula mass of each individual element. So if you look at the bottom of each element, let's look at boron, for example. This is boron. The bottom of boron below the chemical symbol, we see 10.81. That is the formula mass of 1 atom of boron, 10.81. So let's go through a practice exercise. Give the formula mass for each substance. First substance we have is SO2, which is sulfur dioxide. Remember, when we're calculating the formula mass, we have to take into account every single atom we have present. In SO2, we have 1 atom of sulfur and we have 2 atoms of oxygen. 2 oxygen atoms, all right? Now, in order to calculate the formula mass, we have to go back to our periodic table and we have to look at the formula mass of sulfur and the formula mass of oxygen. The formula mass of 1 atom of sulfur is 32.07. The formula mass of 1 atom of oxygen is 16.00. Right? So we need to remember that. So here we have sulfur. We know that 1 atom of sulfur has a formula mass of 32.07, and the units are AMU, which are atomic mass units. We have 2 oxygen atoms. Now, 1 oxygen atom has a mass of 16 AMU, right? But we have 2 oxygen atoms present, so we have to multiply this by 2, right? And that's going to give us the total number of atoms of oxygen that we have present. So we do our calculation. We have 16 times 2, which is 32, and we add that to 32.07, and so our answer is going to be 64.07 AMU. So the formula mass for sulfur dioxide is 64.07 AMU. Again, all we did was we added up the formula mass of each atom that we had present. We had 1 atom of sulfur and 2 atoms of oxygen. Okay? Let's go to our next one, sodium. This is very easy. We look on our periodic table. We can't do this unless we look on our periodic table. The formula mass of sodium is 22.99. So the formula mass of sodium is simply 22.99, and we always need to attach units to any number that we have. The units would be AMU, atomic mass units. Easy, right? All right, let's try a little more challenging one. Magnesium hydroxide, MgOH2. So let's take into account every atom we have present. We have 1 magnesium atom. Because we look to the right of magnesium, there's no subscript, so that means there's only 1 atom present. Now we look at this OH in parentheses. Because it's in parentheses, that means each individual element in the parentheses has 2 atoms present. So we have oxygen, which has 2 atoms present, and we have hydrogen, which also has 2 atoms present. So we need to take into account 2 atoms of oxygen and 2 atoms of hydrogen. So we look on our periodic table. The formula mass of magnesium is 24.31 AMU. The formula mass of oxygen is 16.00, but we have 2 atoms present, so we have to multiply 16 times 2. Hydrogen has an atomic mass of 1.01, but we have to take into account that we have 2 hydrogen atoms present, so we have to multiply that by 2. So now we just do our simple math. So we have 1.01 times 2, and that's going to give us 2.02. I'm going to write this down here, 2.02. Then we have 16 times 2, which is going to give us 32. Okay, and we're going to add that to 24.31. And so when we add all of that together, we're going to get 58.33. So the formula mass for magnesium hydroxide is 58.33 AMU. Simple enough, right? Let's try another one. CH3, CH2, NH2. Now the longer these formulas get, don't make them more complicated than what it is. The key is write out every element you have, write out how many atoms of each element you have. So in this formula we have carbon, hydrogen, and nitrogen, right? We have 1 atom of carbon here and then a 2nd atom of carbon here. So we have 2 carbon atoms. We have 3 hydrogen atoms here, right? That 3 subscript tells us 3. We have 2 hydrogen atoms here. That 2 tells us that we have 2. And we have another 2 hydrogen atoms here for a total of 7 hydrogen atoms. And then of course we only have 1 nitrogen atom. So we look on our periodic table. The formula mass for carbon is 12.01. Now we have to take into account we have 2 carbon atoms present, so we have to multiply that by 2. Because remember, what we see on the periodic table only tells us the mass of 1 atom. We have 7 hydrogen atoms, so we say 1.01 times 7. And we have 1 nitrogen atom, so we say 14.01 times 1. Okay, and we're going to do the math on this. We have 12.01 times 2. We have 1.01 times 7. And then we also have 14.01. So when we add all of this up, we're going to get 45.1 AMU. Okay. So the total formula mass for CH3, CH2, NH2 is 45.1 AMU. And let's try a last one, chlorine 2, Cl2. That means we have 2 atoms of chlorine, right? So we look on our periodic table, and we see the formula mass of 1 atom of chlorine is 35.45. So 35.45, we have to multiply that by 2, right? Because how many atoms of chlorine do we have? We have 2 atoms of chlorine. 35.45 times 2, and that gives us 70.9. And and our units are going to be AMU, 70.9 AMU. All right, so now you should know how to calculate the formula mass of any substance, any compound, or any element. If you have any questions, please let me know.